This is the second part of a video related to this question here. A team of 5 people is required to perform a particular task. We are selecting from a group of 10 people, 7 women and 3 men. How many selections are there? Now we've done 3 already. Okay. How many selections are there altogether? How many if one of them of the men? How many if one of the men must be chosen and okay, is an expert because he's an expert. 2 people do not get on and can't be on the same team. Okay, so the next one of these scenarios is as follows. If the group must contain 3 men, 3 women and 4 men. Group must contain 3 women and 2 men. Okay. Now, this specifically is what some people would know as the hypergeometric distribution. You don't actually have to know that, but if you want to sort of Google stuff or something like that, you might sort of look for the hypergeometric distribution. Okay, so we have 5 spots altogether on our team. Okay. And 3 of them are reserved for women and 2 are reserved for the men. Okay, so we have 3 spots here for the women, but there's 7 women altogether to go into those 3 spots, whereas there are 2 men to go into those 2 spots. Okay, so what we have to do here is, and also it's the multiplication rule is going to come into play here. So for example, we have 3, let's just actually, how many ways are there of picking 2 men from 3? So 3 choose 2 is 3 times 2 times, or actually sorry, I'll just do that fully. I've done a lot of this in the last video, but I'll just do it here again. This is 3 factorial over 2 factorial times 3 minus 2 is 1, so that's 1 factorial. So let's just say for argument's sake, so 3 factorial, 3 factorial is 3 times 2 factorial over 2 factorial times 1 factorial. 1 factorial is just 1. The 2 factorials cancel out, so the answer there is 3. Now I did a load of those choose operator, binomial coefficient things in the last case. So let's just say for argument's sake our men are A, B and C. Our choices are AB, AC or BC. Okay, those are our 3 choices when we pick from A, B, C. Now for each of those 3 choices there is how many ways we can get 3 women picks 3 women from 7. So essentially what we're going to do here is use a multiplication rule. Okay, is what I'm getting at. So for each of these 3 scenarios, there's the 7 possibles. There's the number of ways we can get a committee of, or a group of 3 women from 7 for each of these 3 scenarios. So essentially what our answer is going to be is going to look like this. Okay. So from 7 choose 3 times from 3 choose 2. Okay, and we've already found that to be 3. Okay, so 7, so we'll just do this part here. So that is equal to 7 factorial over 3 factorial. 7 minus 3 is 4 factorial. Okay, and that is equal to 7 times 6 times 5 times 4 factorial. We could stop there because we have 3 by 2 by 1 by 4 factorial. The 4 factorials cancel out. Okay, the 6 cancels out with the 3 and the 2, so what we left is 35. Okay, so the number of ways we can have 3 men and 2 women is 35 times 3, and that's equal to 105. Okay. Now, just as a remark, I'm just going to go back to an earlier question here. A team of 5 people is chosen to perform a particular task. We are selecting from a group of 7 women and 3 men. How many possible selections are there altogether? We found that to be 252. Okay. So what I'm going to sort of say here is that the probability of 3 women and 2 men is 105 divided by 252. What is the how many ways can you randomly select 3 women and 2 men from that 10 people? How many of them would be randomly selected? How many groups of 5 would contain 3 women? Essentially, what's the probability of that? You can work that out, but it's essentially around 40%. And that is specifically those probabilities are specifically the hypergeometric distribution. That's not really a part of this question. I just wanted to sort of remark about why I had that many. Okay. Now the next part. If the group is this is part 5. And what we're asked to do is, if the group, how many selections are possible if the group must contain more women than men? Okay. One thing to remark is that we're picking 5 people, and that means can't have equal number of male and female. You think, why is that important? Okay. Because you can either have more women or you can have more men. And there is only one way you can have more men. Let's just think about this for a second. What is the opposite of more women than men? It would be more men than women. And what does more men than women mean? It means all 3 men are selected. Okay. So this actually seems like a very difficult problem, but if you break it down, and as something you should always consider in probability is the complement, because quite often a problem can be massively simplified if you look at the complement. Okay. What all 3 men are selected. Okay, that means that essentially we're only picking A, B, and C. Let's say they are men. Are already selected, and we got 2 spots left. Okay. So how many ways are there of picking 2 women from the remaining 7, or from the 7 women picking 2? Okay. So that is how do we do that? So how many ways are there if all 3 men are selected? So from 3, choose 3. That's just 1. There's only one way you can do that. Times 7, choose 2. Okay, so I'm just going to ignore that. From 3, choose 3. That's just 1. But from 7, choose 2. That is, let's do that actually. It's from 7, choose 2 is 21 ways. Okay. Now, there are 21 ways. I'll just remark upon that again. 21 ways that there are there are more men than women. Okay. Now, So the next thing to consider is there are 252 ways altogether of picking a committee. Or picking our group. Okay. So let's just see how that goes. That means that there has to be 252 minus 21 ways. And what is that? That is 231. There has to be 230 ways we can select. Let's just make more space there. We can select more women than men. Okay, so this is quite a lot. This is actually quite a neat way of doing it. Okay, by sort of must contain more women than men. Okay. You just remember you can't have an equal number of males and females. If you can, you could actually just have to sort of factor it in. Okay. Consider how many ways you can get more men than women. Okay, and that in this case that's quite an easy one because you have to pick 3 men from 3. Okay, and there's only one way you can do that. And for the remaining 2 spots, how many ways can you pick? So this is the males. And let's say the females. How many ways you can pick the remaining 2 positions from 7 females? There's 21 ways. And so there are 21 ways you can have more men than women. There's 252 altogether. We found that at the very first question. Okay, that was that was actually question 1. Just in case you didn't catch that, how many ways are there getting them all together? And so the answer is 231. Okay, there's a lot to think about there. So now the last question is this video is already quite long. The last one is question is more men than women. Now we actually answered this one already due to the technique I used. The answer there is 21. Okay, and we use this to. It's a sort of. This will put in last. This is question, or this is the 6th part. This is the last part, not to make it the last question too obvious how to do it. How many ways can you get a tie? Equal number. Just to say I asked that. Equal number. Well, if we're picking 5, that's impossible. Okay, but something to think about, just in case we're picking 6 people rather than 5 people. Alright, so that's this probability question done.